find all zeros of the polynomial x to the 7th plus 4x to the 6th plus 7x to the 5th plus 11x to the 4th minus 8x cubed minus 15x squared. Our first step on this will be to factor. The reason behind that is all of these have an x squared in common. So we take out that common factor, and this leaves us with x to the 5th plus 4x to the 4th plus 7x cubed plus 11x squared minus 8x minus 15. We're trying to find all the zeros, so that amounts to setting each factor equal to 0. So this gives us the equation x squared equals 0 and x to the 5th plus 4x to the 4th plus 7x cubed plus 11x squared minus 8x minus 15 equal to 0. Now this first factor, we can conclude from this that x equals 0. So that one's done. Now to move on to the second one, we're going to have to use maybe the rational zeros test, synthetic division, and so on. So to get started on this, for the rational zeros test, we know that the rational zeros of this function have to be of the form q over p, where q represents any factor of the last term, and p represents any factor of the leading coefficient, which in this case is 1. So this gives us, for our set of factors, 1, 3, 5, and 15, and any possible sign, positive or negative. Okay, so our next step will be to see if we can eliminate any of these by using Descartes' rule of signs. So this is where we count the sign changes. If we look at the sign changes in the original function, I see it's positive for a long time, and then it switches negative and stays that way. So there's only one sign change. And this tells us that there is one positive real zero. If we look at the sign changes, if we look at the negative real zeros, so this amounts to replacing all the x's with negative x. This gives us the new polynomial negative x to the 7th plus 4x to the 6th minus 7x to the 5th plus 11x to the 4th plus 8x cubed minus 15x squared. If we count the sign changes here, I see we've got 1, 2, 3 sign changes, then it stays the same, and then we've got one more. So there are 4 sign changes, so that says that we have either 4 or 2 or 0 negative real zeros. Now, so far this doesn't really help because this didn't let us get rid of any of the possibilities for our zeros. So we'll just have to do a little bit of trial and error with synthetic division to see what we can come up with. So I'm just going to go through the list. I'm going to start out with x equals 1. And I'm going to use that for my first attempted zero on this. I'm going to set up the long division bar, the synthetic division bar, and write in the coefficients of the original polynomial. We had 1x to the 7th plus 4, I'm sorry, not the original, this new factored up version. So 1x to the 5th plus 4x to the 4th plus 7x cubed plus 11x squared minus 8x minus 15. We go through the synthetic division process. We bring down the leading coefficient and then multiply. 1 times 1 is positive 1. If we add these together, this gives us 5, and then multiply. 1 times positive 5 is positive 5. If we add these together, we've got positive 12. And then multiply. 1 times positive 12 is positive 12. Adding these together, we have positive 23. And then multiply. 1 times 23 is 23. We add these together, we've got positive 15. And then multiply. 1 times 15 is 15. If we add these together, we get a remainder of 0. This is good. This tells us that x equals 1 is a 0. Even better, though, we have found a positive real 0, and we know from up above that there is only one positive real 0. So we know that we don't need to bother testing 3 or 5 or 15 or even 1 again. None of those will work. We found the only positive real 0. So now we're going to move on and test the negatives. So I'm going to try negative 1 for my next guess on a 0. And we'll do synthetic division again on this. So first we bring down the leading coefficient. We have 1, and then multiply. Negative 1 times 1 is negative 1. We add these together, we get positive 4, and then multiply. Negative 1 times positive 4 is negative 4. Adding these together gives us positive 8, and then multiply. Negative 1 times positive 8 is negative 8. And then we add to get positive 15. Negative 1 times positive 15 is negative 15. We add these up to get a remainder of 0. That's good. That says x equals negative 1 is also a real 0. Let's continue and try our next 0 in the list, x equals negative 3. So we'll go through and set up the synthetic division again. So we bring down the leading coefficient and then multiply. Negative 3 times 1 is negative 3. Adding these together, we have positive 1. Negative 3 times positive 1 is negative 3. Adding these together, we have positive 5. Negative 3 times positive 5 is negative 15. Add these together and we get 0. This is good. This says that x equals negative 3 is a 0. Now if we look at this, the original polynomial that we started the synthetic division with was degree 5. The first successful synthetic division reduced it to degree 4. The next reduced it to degree 3. This last one reduced it to degree 2, so we have a quadratic. 1x squared plus 1x plus 5. And we want to find the zeros of this. I don't see a way to factor this, so I'm going to use the quadratic formula. This gives us x equals negative b. Here the a is positive 1, b is positive 1, c is positive 5. So we've got x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. We simplify this and get negative 1 plus or minus the square root of negative 19 over 2. 19 is prime, so we can't simplify the radical other than to bring the negative out as an I. This gives us negative 1 plus or minus I radical 19 over 2. Now we were originally asked to find all the zeros of this polynomial. Let's count the ones that we have so far. We found x equals 0 initially. Then with synthetic division we had x equals 1, x equals negative 1, x equals negative 3. So that's 4 answers so far. And then we have 2 answers that are complex conjugates. That gives us 6 answers, but we need 7 because this is a degree 7 polynomial. So this seems like a problem until you remember that this x equals 0, this was actually a 0 of multiplicity 2. So x equals 0 actually came up twice. So this counts as 2 zeros. That's our third 0. That's our fourth. X equals negative 3 is the fifth. And then our 6th and 7th are the conjugate pairs. So we found all 7 zeros.